Hello, welcome back. In this video, you're going to learn about point-to-point protocol or PPP. So let's look at the agenda. The concept of PPP will be discussed. After that, framing structure of PPP will be the point of discussion. Then various transition phases will be discussed. After that, multilink PPP. What is the concept of PPP? Actually, PPP is a byte-oriented protocol. Previously, we have seen HDLC, which is a protocol that is used for multi-point as well as point-to-point connection. Now, this PPP is a protocol that is dedicated for point-to-point connection. Millions of internet users are using PPP to access the channel. Now, there are certain services that are provided by PPP, or we can tell that these are the advantages. At first, PPP defines the frame format. It can also help in negotiation for link establishment and data transfer between two devices. Then the various network layer data encapsulation can be done in the data link layer in PPP. Authentication mechanism is present. Multiple network layer services can be accessed. Connections over multiple links is possible, and network address configuration is possible in PPP. But to make it very simple, there are certain services that are absent in PPP. So let us look at the disadvantages of PPP. There is no flow control mechanism in PPP. The error control is very simple, and there is no sophisticated addressing mechanism for multi-point configurations. Let us look at the framing structure. Since PPP is a byte-oriented protocol, so the framing will be similar to that discussed in the byte-oriented protocol framing in the previous videos. So here, as before, byte stuffing is also done, so that if there is an escape byte present in the data byte, then it should be eliminated. So the byte stuffing or the escape byte is 01111101. So it is 8-bit escape byte. So this is the framing structure of PPP. It has several fields. The first one is the flag field, consisting of 1 byte, and the flag field is 01111110. Then we have the address field, which is of 1 byte, and the address is all ones. Next we have the control field, which is also of 1 byte. It is 11 followed by 6 zeros. After that we have 1 to 2 bytes of protocol field. Then comes the payload field, which is variable in nature. After that, error detection field, which is also known as a frame check sequence, and it uses the cyclic redundancy check type of error detection technique. It consists of 2 or 4 bytes. Lastly, there is another flag of 1 byte. There are various transition phases of PPP. The first phase is the dead phase. Dead phase basically means link is not being used. Next phase is the established phase, where link is established by any one station. After that, this is an optional phase known as authentication phase, and authentication is done between two devices. After that, it is the network phase, where network layer protocols are configured. Next is the open phase. In open phase, data is transferred. Then we have the terminate phase. In terminate phase, the link gets terminated. Let's understand this with the help of this flow diagram. So this is the dead phase. Here the link is not being used and the carrier is dropped, and it goes to the terminate phase. In the established phase, one of the parties can try to establish the link with the other party. If it goes to the dead phase, if the link is not being established, and from the dead phase, if it finds the carrier or detects the carrier, then it goes to the established phase. From the established phase, it can go to the authentication phase. This is optional and it has to be agreed by both the parties. If authentication is successful, it goes to the network phase. Here network layer configuration is done and it goes to the open phase. In open phase, data gets transferred. So this is the overall structure of transition phases of PPP. Multiplexing can be done in PPP, although it is a data link layer protocol, but still it can use various other protocols from other layers to do multiplexing. It can use link control protocol or LCP, and it can use only one link control protocol, and this is done to establish, maintain, configure and terminate the links. It can use two authentication protocols, also called APs, and authentication protocols are used to validate the user identity. Now there are two types of authentication protocols. One is called the PAP or the PAP. This is the password authentication protocol, and the second one is the CHAP or CHAP. This is challenge handshake authentication protocol. Now let us see how PAP works. So this is the flow diagram of PAP. It starts with the user. The user sends an authorization, identification and password to the system. The system checks the data, and if it is valid, it accepts it, and if it is not valid, it rejects it. So when it is valid and it accepts it, then the user can access the system. Let us understand how CHAP works. This is much more sophisticated and it provides security also. So the user has a predefined function. There is a predefined function and the system sends a challenge value to the user. The user, along with the challenge value and the predefined function, produces a result. Now this result from the user goes to the system, and the system again performs the same function, that is, it uses the same challenge value and the predefined function and produces a result. These two results are then compared with each other. That means result from the system and the result from the user. If they are same, then the system accepts the user and the user can access the channel, and if it is not same, then the user rejects it. It can use several network control protocols or NCPs from the network layer protocols. Like it can use Internet Protocol Control Protocol. If it is using TCP/IP model, then it uses OSI Network Layer Control Protocol if it uses the OSI model, and it can use Xerox NS IDP Control Protocol for Xerox network. For exchange of data packets from the network layer, the packet format is like this. The IP packet format goes like this. There is a header part as usual and the user data part. And this is basically the payload part, which is payload part plus padding. You have the header part as well as the user part. And if it uses the IP, then the field prior to the payload will be set to 0021. Otherwise, if it uses the OSI model, then this field will be 0023. Now, PPP is mainly used to transfer data between two devices, that is point-to-point link. But it can also be used for multilink PPP. So, logical PPP frame should be divided into several actual PPP frames. So, here we can see that there is a logical PPP frame having the payload. So, several parts of the logical PPP frame will form the payload part of the actual PPP frame. So, there can be several channels like channel 1, channel 2, channel 3 and channel 4. So, if the protocol field is set to 003D, that means this logical PPP frame is divided into several actual PPP frames and they are then used for multilink PPP. To summarize, in this video, we have learned about the concept, the advantages and disadvantages of PPP. We have learned about the framing structure of PPP, then the various transition phases of PPP, followed by multiplexing, and then at the end, we have learned about the multilink PPP. Thank you.